Here's another example using trig substitution. I want to do the integral of the square root of 9 minus x squared over x squared dx. And so on the side here, I'm getting ready to do the trig substitution. And I have the square root of 9 minus x squared, which equals the square root of 3 squared minus x squared. So that one is in the form of the square root of a squared minus x squared. The trig substitution for this will be x equals 3 sine theta. Don't forget, you're going to have to go ahead and find out what dx equals. You have to do a substitution for the dx as well. So the derivative of x with respect to theta is going to be 3 cosine theta. So dx will equal 3 cosine theta d theta. This will give us this in this problem, the square root of 9 minus x becomes 3 sine theta. So that's 3 sine theta. Since it was x squared, that whole thing is squared. And the denominator, I had x squared, so the denominator becomes 3 sine theta squared. Dx is 3 cosine theta d theta. From here, I will do some simplification in the problem. I am going to square 3 sine theta in both the numerator and the denominator. In the numerator, I'll have the square root of 9 minus 9 sine squared theta. And in the denominator, I'll have 9 sine squared theta. And then from that dx, I'll have 3 cosine theta d theta. In the numerator, I'm going to factor a 9 out. That's under that square root sign. I'll write it like this. The square root of 9, open parentheses here, 1 minus sine squared theta. All of that is under the square root sign. And the denominator is 9 sine squared theta. And then here, all of that multiplied by 3 cosine theta d theta. This square root of 9 times 1 minus sine squared theta, I can really write that as 2 separate square roots. There's a little property of square roots that you probably have seen a long time ago. If I have the square root of a times b, I can say that's equal to the square root of a times the square root of b. It's important to remember this does not work if this is a plus sign here instead of a multiplication sign. As long as it's multiplication, and here we have multiplication right there, I can say that's going to be the square root of 9 times the square root of 1 minus sine squared theta. And then I'll have over 9 sine squared theta times 3 cosine theta d theta. Let me separate off this thinking part right there. Here, the square root of 9 is 3. There is a trig identity for 1 minus sine squared theta, and it's cosine squared theta. So simplifying this, square root of 9 is 3. 3 times the square root of cosine squared theta. This is over 9 sine squared theta. And then times 3 cosine theta d theta. In fact, this you could put it over 1. Let's start reducing. I can reduce, well, in fact, the 2 3's, 3 times 3 is 9, but I can reduce both of those with the 9 that's on the bottom. And then I can say the square root of cosine squared theta equals cosine theta. So cosine theta times cosine theta over sine squared theta d theta. And so this will equal the integral of cosine squared theta over sine squared theta d theta. And now from trig identities, I know that cosine over sine is cotangent theta. And in fact, if you have cosine squared theta over sine squared theta, that's going to be cotangent squared theta. So we'll go to a new page on this, and I'll put equals here. I'm going to write the last step from the previous page. So the integral of cosine squared theta over sine squared theta d theta, that's going to equal the integral of cotangent squared theta d theta. Now there is an identity for cotangent squared theta, and it's cosecant squared theta minus 1. So I'm going to substitute that identity in here. The integral of cotangent squared theta d theta will become the integral of cosecant squared theta minus 1 d theta. I prefer to take something like this and separate it into two integrals because I want to remember that's what it is. This will be the integral of cosecant squared theta d theta minus the integral of 1 d theta. The first part of this, the integral of cosecant squared theta. Cosecant squared theta, that's the derivative of something. And if you remember your derivative rules, this cosecant squared theta is the derivative of negative cotangent theta. Or the derivative of cotangent theta. I'm going to write this on the side just to, well, this would be a theta, just to have it here. The derivative of cotangent theta is negative cosecant squared theta. So if I have the integral of cosecant squared theta, that's going to be negative cotangent theta. So this part's negative cotangent theta, and the antiderivative of 1 is theta. 1 d theta, the variable is theta, so I'll say that's theta. Now I have got to go back to the original variable of x. So at this point, I need to go back and recall what the substitution was. It was x equals 3 sine theta. So x over 3 equals sine theta. And I can remember sine is opposite over hypotenuse. Let's draw the triangle for this. Draw a right triangle. Pick an angle to be theta. Not the right angle, but one of the others. And then sine theta, the opposite side over hypotenuse. With the Pythagorean Theorem, you can find the third side. So if I call the third side, well, let's call it z or something like that. So I want to find z. Z squared plus x squared equals 3 squared. So z squared is, well, 3 squared is 9. 9 minus x squared. So z is the square root of 9 minus x squared. So that third side, square root of 9 minus x squared. Now here's the answer I've gotten. Now this still has theta in it. We have to change it back to x. So cotangent theta, we'll read it from the triangle. Let's see, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is going to be adjacent, which is the square root of 9 minus x squared, over opposite. Don't forget you have that negative sign that was in front of cotangent. And then I have to find theta on this problem. And in fact here, x over 3 equals sine theta. So using inverse trig functions, I could say this. Here I'm going to write x over 3 equals sine theta. So I could say inverse sine of x over 3 is theta. So there's theta. So I'll have minus inverse sine of x over 3. Don't forget the plus c, and there is the answer to this problem.